Alright, in today's video we're going to be going through the examples on the Module 1 or Chapter P lecture guide. So at this point, I'll ask that you have gone through and looked at these examples on your own before using this video. Specifically for example 1, this is in section P.1 in the textbook, so make sure you go read through at the very least the beginning piece, the setup and the discussion of this section before you continue. So, to continue this example, Johnson and Goldstein recruited 161 participants for a study to address the question of organ donor recruitment. So in classes before, I've been able to ask people on the spot, who here believes organ donation is a good idea? Almost everyone raises their hand. And then I've asked, who's an organ donor? And you get much less hands raised. So this is the type of problem that these researchers were interested in. So, how did they try to attack this problem? Well, what they did was they created this pretend driver's license application, as the problem describes. And what they did was they decided, okay, we're going to try a couple different methods to get people signed up to be organ donors. So the three methods are below. Number one is, they called this the neutral group. Some of the participants on their form were forced to make a choice of becoming a donor or not without being given a default option. Alright, so there was a question there where they had to pick one or the other of those two options but weren't put in a default group. Number two is, some of the other participants on their form were told that the default option was to not be a donor, but then they could make the active choice to switch that and become a donor. That's the opt-in to being a donor group. And then third is, the other participants on their form had an option that was, by default, you are signed up to be a donor by completing the form at all, and using this form, you have to opt out of becoming a donor. So by default, you're in, you have to opt out. So those are the three different ways they set this up. So part A of this problem says, what is the research question that the researchers are trying to answer with this study? And the answer that I put for that was, can a method increase the likelihood that a person agrees to become an organ donor? So what we're trying to figure out is, depending on how I ask you to become an organ donor, will that make you more or less likely to actually say yes? And we have those three different types of scenarios above, the neutral, opt-in, and opt-out. And so our question is one of these better than the others? And if so, then that gives us evidence that that might be how we should be posing this question to try to get more people signed up. Okay, so part B says, describe the observational units, the variables, and if those variables are quantitative or categorical. So, observational units from above. Remember, the observational units are, what are you actually looking at to get the data? So let's think about this. Well, we've got a participant in this study who fills out the form. What do? We look at their form and we're getting information from them. And so the observational units are going to be those participants. Every participant gives us information. Okay, well, that's a little tough to see, I think, sometimes. So one way you can do this, kind of going backwards, is start with the variables. If you're having trouble with the observational units here, just go to the variables and say, well, what are the variables? What's the information I'm getting? And there's two of them here. One of them is organ donor. Did you say yes or no to becoming an organ donor? So each person that's filling out one of these applications, when they get to this question, is either becoming an organ donor or agreeing, even though it's all pretend, agreeing to become an organ donor or not. So that's one variable here. Did you say yes or no to becoming an organ donor? This is categorical because, look, I've got two boxes. You either are in the yes or the no box. The other one is the method of asking. So this was the method that they used to ask the person to become an organ donor. And this was just the three groups that we had, the opt-in, the opt-out, and the neutral. And again, that's very naturally putting into boxes, so we're going to call that categorical. So our two variables, both categorical, are, how did I ask you to become an organ donor? 3 options. And did you say yes or no? Boom, that's it. From each participant, I can get those 2 pieces of information. What did the results say, or what did they find? Well, if you go back through the book, you see that both the neutral and opt-out options produced a higher percentage of people who agreed to become organ donors. So they provided a chart. So here's the chart that they gave in the book. And we can see here, what we want is that these donor bars are larger, because that means a higher percentage of the people in that group said they would become donors. And we see here, it looks like a pretty good, decently sized, bigger bar is here in opt-out and here in neutral. And then this opt-in bar is smaller than the other 2. And so at this point, we don't really know if that difference is enough to say that this, the method caused it, right? We don't know, or is this difference here, really big enough to say there's a difference, or could this have just been by chance? Because again, we only asked a couple people out of the millions of people who go through this process or could become donors. So there's lots of things we'll learn about in this class where we have to dig into this. But just by looking at it, I would agree that, yep, it looks like the opt-out and the neutral groups were better for getting people to sign up to be donors. And specifically, it was 78.6% said yes to be donors in the neutral, that's here, 41.8% in the the opt-in group, that's not great, and then 82% in the opt-out group. So definitely better for the opt-out in neutral. All right. So in example 2 in this study, the researchers were looking at the connection between the number of hours you spend trying to perfect a skill, such as music or a sport, or the amount you practice. How does that correspond to how good you will be in that sport or music or whatever thing that you're going to try to practice? So the researchers in the study asked violin students at the Music Academy of West Berlin to keep a diary indicating how they spent their time. They also then, to try to get a baseline at the students' talent, went to the professors and had the professors say who were the top students, who were good students or violinists but not the best, and who were studying to become the music teachers. So what they did was, right away, I want you to be thinking to yourself, okay, what info am I getting? Because to me, I hear that immediately and I go, that sounds like 2 different ways of thinking about information or data about these violinists. So that's making me think, variables. Okay, so continuing on, it said researchers found that those in the top 2 groups, the soloist types and the good but not the best types, had devoted much more of the time per week to practice than the group studying to become music teachers. So, part A, identify the observational units. Okay, we clearly have data we're getting, right? So in the last line, there was the type of student, then you also saw a connection with the amount they practice. So these are all variables, info we're getting. But where are we getting them from? We're getting them from the violin students. So the observational units here are the people or things that we're getting information from. In this case, we're getting info from or about the students. Okay, so now that we know the observational units are the violin students, that's where the information's coming from. We have to think about, well, what's the information? So part B says identify the quantitative variable in this study. Quantitative, numbers. So go back to this line. It's all in this line here, right? I'm looking for some description of violin students that makes me think of numbers. So I see those in the groups, no, that's type, that's not a number. And then I see devoted much more time per week, time, number. So as soon as you see time, you should be thinking, oh, that sounds like something with numbers. So I specifically focus on this. They devoted more time per week to practice. That is a description of a violin student that uses a number. Boom, quantitative variable. The quantitative variable here is the time spent per week studying, because that's a way to describe information to describe the observational unit. Okay, well, at the beginning we had a different way of describing the students, right up here. It says, identify the categorical variable. So, what was a way we could describe each student that would put them in a box? Well, we had their professors put them in boxes. The boxes were top student, good student or good violinist, and then those studying to become teachers. So, type of violinist is the categorical variable. It's like the umbrella that describes all the different options. And those options were the top students trying to become soloists, the good students but not the best, and then the teachers, which how you read this could make it sound bad for the teachers, so ouch. Next one, example 3. So this one is about tattoos. So in this example, you want to consider the students in your class as observational units, and you're trying to run a statistical study about tattoos. So for each of the following, it says indicate whether you're a categorical variable, a quantitative variable, a research question, and therefore not a variable at all. And that was the last option. So, part A, how many tattoos the student has. So let's think about this. Go back and focus on this real quick. The students in your class are the observational units. So all of our questions are going to kind of be focused on that line right there. So if the students are the observational units, then every variable should be a piece of data, some information I'm getting from each student. So let's ask ourselves, how many tattoos does a student have? That is a piece of information I grabbed from a student. So we should feel comfortable with that being a variable. And some of these keywords you can look for, how many being a number, I can count it, so that's quantitative. All right, B, whether male students are more likely to have a tattoo than female students. So I'm thinking about that and I'm saying, is that something that represents data I could get from each individual student? And here's where this is tricky. To answer this question, I definitely need to get information from all of my students. But this is not describing one piece of info from every student. This is a question about all students that I'm interested in. And so as soon as we get to something that's about all students, then we're much likely a research question. And so this one, whether male students are more likely to have a tattoo than female students, is a research question. Okay. C, whether or not the student has a tattoo. Categorical. It's a variable because it's about each student, right? Each student, this line talks about info about them, right? I could ask you, do you have a tattoo? You could ask the next student, do you have a tattoo? Now, it's categorical because your answer to that puts you in a box, right? What's your answer? Do you have a tattoo? If you said yes, you're in the yes box. If you said no, you're in the no box. Boom. D, which subject the student is majoring in. Well, again, it's about each student. So each student, I could grab them and say, which subject are you majoring in? And I'd be able to get information from them. So that's telling me variable. Now, is it categorical? Well, does the answer to that put you in a box? Yes, it does. If you tell me your major is, I haven't picked yet, you're in a box. If you tell me it's math, you're in a box. If you tell me it's communications, you're in a box. So because the answer puts you in a box, you're categorical. Part E, whether students majoring in liberal arts tend to have more tattoos than students majoring in engineering. Again, this is a statement or question about all the students you want to answer. And because it's not something that we can apply directly to each student individually to get data, it's not a variable. The only option, you are a research question. Awesome. Let's keep going. So example 4, go check out the video on sampling the class survey on Blackboard. This is important because you're going to need this for your activity, your pre-class activity for this first week. All right, and the last example, example 5. So explain in your own words what it means to say the probability of for each statement below. Now here's the kicker. do not include the words probability, chance, odds, or likelihood, or any other synonym you try to sneak in there of probability. When I do things like this, where I've done them in the past, I don't put that last bit, and I say, what's the probability of getting a red M&M candy? People say the chance of, the likelihood of, and you're just kind of sidestepping the problem without trying to actually get to what probability is. So the probability of getting a red M&M candy is 0.20, and I'll just put a little extra on this, right? Or 20%. Well, that says 20%. So in case you're a little bit more comfortable with percentages, you can always just convert that if it makes it better for you. Okay, what does it mean to say the probability of getting a red M&M candy is 20%? So the setup here is I've got a bag of M&Ms, or maybe I've got this big vat of them. I don't know where you got that, but that would be great. And you pick one out. The probability of getting a red M&M being 20% means that if you were to repeat that over and over again, let's say you had a vat of all the M&Ms in the whole world. You pick out an M&M. You look at it. It's red. You mark it down. You pick out another. It's yellow. You mark it down. You keep going. You keep going. You keep going. You keep going. In the long run, when you've done it over and over and over again, and then you look at your results, you should expect that 20% of those M&Ms you picked out was red. So I know that it's weird to think about it that way, but probability to us is not about the individual event. Probability to us is about the proportion in all of these cases that an event occurs when you do it a bunch of times, a bunch of times. So you probability, I know you hear probability and we all try to use it to just tell us what's going to happen next, but that's not how probability works. Probability is all about the long run. It tells us what happens eventually over a long period of time, not about what will happen next necessarily. Okay, next one. The probability of winning at a daily number lottery game is 1 out of 100. What does that mean? Well, in the long run, about 1 out of every 100 tickets will win the daily number. So, if you grab a ticket, right, and you want to play this game, you might say, I've got a 1% chance of winning. So, when I say that to you, you might correctly say, well, that's not very good. 1%'s not good. True. That is a fine interpretation of what this sentence means. But if we're speaking strictly in terms of probability here, right, what your probability of winning being 1 out of 100 means is that if I bought many tickets, if I bought millions of these tickets, I would expect that 1 out of every 100 tickets is a winner. That's the idea. So, you got to be careful though, right? If I go buy 100 tickets right now, am I guaranteed that I'm going to have one winner? Absolutely not. Because it's the probability, there's still random chance. It's just in the long run, many tickets. You expect about 1 out of every 100 to be a winner. And the more tickets you buy, the closer your proportion of winners will get to 1 out of 100. Okay. The probability of rain tomorrow is 0.30, or again, if it's easier for you, 30%. We've seen this all together, right? We've all looked at the forecast and said, oh, is it going to rain? And we said, oh, it says 40% rain. And everyone's looking around like, what does that mean? This is the least helpful pieces of information I've ever been given. Which is fair. Because what does it mean? Well, it's a little, convoluted, but how do we know it's going to rain? Well, what happens is we have models of weather, and based on those models, we can predict whether it's going to rain or not. And if they say something like 40% chance of rain, what they really mean is if I was to simulate tomorrow many times based on my weather model, in about 30% of those simulations, it's going to rain. Or another way you could say that is, if you were to gather up over the years all of the days that were going to be very similar to tomorrow in terms of weather patterns, then 30% of those days, 3 out of every 10 of those days it rained. All right, So that was it for this section. Make sure you keep going over these ideas. Remember, these vocab words, you don't need to have them down right away, but just keep practicing, keep practicing, keep practicing, and make sure you ask me any questions when you have them.